Let me begin by recapping some material from our last class. We had a formula which describes exactly how the Fed can influence the nation's money supply. And what is that equation? That equation is that the money supply or M superscript S is equal to the monetary base times the money multiplier. Right? Now, what is the monetary base? Do you recall what the monetary base is? The monetary base consists of cash with the public plus the cash reserves of banks. Right? The money multiplier that we have so far, we've derived this to be equal to 1 divided by the required reserve ratio expressed in decimals. So if the RRR were 10%, we'd write 0.1 down here. Correct? Now, we can take this equation and convert it into a change form, meaning that I can add to this a triangle like that. So that would be the change in the money supply. And then we'd add a triangle to this, change in the monetary base. Now, there is no triangle next to the money multiplier because that doesn't change. That's simply 1 divided by the RRR. Correct? So when the Fed buys bonds, this change in the monetary base is going to be positive or negative when the Fed's buying bonds from us. Let's think about that. When the Fed buys bonds, it takes, let's say, my bond and gives me money, correct? And I'm part of the public, so wouldn't cash with the public then rise? Correct? And if I then take that money and deposit it in my bank, wouldn't the cash reserves of banks rise? But either way, the monetary base rises. Correct? So this here is positive when the Fed buys bonds. Correct? On the other hand, it is negative when the Fed sells bonds. Is that clear? So this is our principal formula then, right? And this could also then be written in the following form. You could write this as change in the money supply is equal to plus value of bonds bought by Fed times the money multiplier, or minus value of bonds sold by Fed times the money multiplier. Correct? So this really comes out of this formula. Do you follow me? That comes out of that original formula there. Correct? Is that understood by us? Because if the Fed were buying bonds, then of course this change in the monetary base would be positive. Correct? So if the Fed is buying $1,000 worth of bonds, well, that would cause the monetary base to go up by 1,000. Hence, we'd have plus 1,000. You get me? Because the monetary base is going up by 1,000 when the Fed buys bonds worth $1,000 from, let's say, me. So this is, I'm just repeating stuff from our previous class here. There's nothing new. I've introduced nothing new. But now I'm going to mention to you two assumptions. There are two underlying assumptions. There are two assumptions that underlie this formula. This formula is based on two assumptions. And what are those assumptions? First assumption is that banks are fully lent up. Now, what does that mean? Banks are fully lent up. Now, do you remember my story? It all started, if you remember, with me selling bonds worth $1,000 to the Fed. The Fed giving me $1,000, and what do I do with that money? I deposit it in my bank, correct? If the RRR is 10%, my bank needs to hang on to how much of that 1,000 as cash? $100, correct? My bank can then lend out 900 of those dollars, right? And that 900 is borrowed by one of you and you spend it on a new computer in Best Buy. Do you remember that story? And so Best Buy gets that 900, which then goes into Best Buy's bank account, causing the sum total of checkable deposits in the country to go up by a further 900, and so on. So what's the assumption here? The assumption here is that every time a bank receives a fresh deposit, it chooses to keep exactly 10% as a cash reserve. In other words, it lends out the maximum that it is allowed to by the Fed. Correct? That's the meaning of banks being fully lent up. In other words, the only cash reserves the banks keep are required reserves. So if the RRR is 10%, banks keep exactly 10% of deposits as a cash reserve, nothing more. Right? So that's, that translates as banks are fully lent up. Now, what if banks were not fully lent up? What if they decided to hold more than 10% of their customers' deposits as a cash reserve? In other words, when I take my 1,000 that I've just received from the Fed for my bond, I take it to my bank, I deposit it, and my bank decides to hang on to 20% of that as a cash reserve. In that case, how much money will my bank be able to lend off that 1,000? If they decide to hold on to 20% and not the 10% that's required of them. Well, come on, if I deposit $1,000 in my bank and my bank wants to hold 20% of that as cash, 20% of 1,000 is 200. And so my bank will lend out 800 instead of the old 900. Is that correct? And so when you borrow the money, you'll be now borrowing 800, not 900. So how much will you be spending in Best Buy now? 800, not 900. And so how much money will end up in Best Buy's bank account? 800, not 900, right? So if you add up, if you think of that sequence of numbers, the change in the money supply, which used to be like this, right? 1,000 plus 900 plus 8, 10, etc. What will this now begin to look like if banks decide to keep 20% and not 10% as their cash reserve? Well, the first number will be 1,000, all right. But the second number will be, the third number will be how much? 80% of that, which is, do you see? So when you add up these numbers, you will end up with a smaller change in the money supply than this formula here predicts. Is that correct? So this formula is based on the assumption the banks are fully lent up. Because if they aren't fully lent up, meaning if they decide to hold more cash than the Fed requires them to hold, in other words, if they lend less than they are allowed to, then the creation of money will be less, or there will be a smaller creation of money. Remember, when banks lend, that's when new money is created. How's that? Because when banks lend money, the borrower of that money spends the money in a store, let us say, and so that money then ends up in the store's bank account, causing the sum total of the nation's checkable deposits to grow. And remember, checkable deposits are the biggest component of M1, the money supply. Right? So bank lending causes the money supply to swell. Agreed? But if banks choose not to be fully lent up, that would mean the banks are not lending as much as they can. If they're lending less, of course, that will mean that there will be a smaller quantity of money created by them. Yes? So that's our first assumption upon which this formula is based. The second assumption upon which this formula is based is that there are no cash leaks. What that means is that any party who receives money deposits the entire amount in their checking account. When I sell my bond to the Fed for $1,000, the assumption is that I take the entire 1,000 and I deposit it in my bank, which then enables my bank to lend out 900 of that. Correct? But what if I decide to keep a part of that $1,000 as cash in my pocket? What if I decide to keep $100 of that 1,000 as cash in my pocket? I deposit in my bank only 900. And if my bank chooses to be fully lent up, how much of that 900 will it be able to lend? 90% of that 810, correct? So what will the sequence of numbers then look like? The sequence of numbers in that case will look like 1,000, then the next number shall be 810. Do you follow what I'm saying? Because there's a cash leak. And so wouldn't that sum of numbers be less than this formula, what this formula predicts? Correct? So if there are cash leaks, meaning if any party who receives money decides to keep a part of that money as cash, doesn't deposit the entire amount in his bank, then bank's ability to lend again is reduced. Correct? And we know that bank lending is what creates money in the story. If we deposit less in our banks will be able to lend less. Okay? So this formula depends on these two assumptions. What we are going to do now is we are going to relax these assumptions. We are going to relax these assumptions and then see what happens. In other words, we are now going to allow cash leaks, and we are also going to allow banks to hold more cash reserves than the Fed requires them to hold. Correct? We'll now go to a new slide. So once again, I'm going to now first write down a few things here. The money supply by the M1 definition is equal to cash with the public plus checkable deposits plus traveler's checks, correct? But since traveler's checks are such a tiny amount, I'm going to ignore it. Okay? So I'm going to write this as C plus D. Okay? C is cash with the public, D is the checkable deposits of the public. Next, we're going to write the definition of monetary base. The monetary base, if you recall, is cash with public plus the cash reserves of banks. So this, of course, is C, and this I'm going to write as R. Yes? Now we are going to allow for cash leaks. How do we allow for cash leaks? We are now going to assume that people maintain a certain ratio between cash in their pockets and their checkable deposits. People like to maintain a certain ratio between cash in their pockets and their checkable deposits. Right? And let us call this ratio lowercase c. So this then implies that C capital C, which is cash with the public, is going to be equal to lowercase c times capital D. You see, people like to, in other words, keep a certain fraction of their deposits in cash form. This is now allowed for cash leaks, am I correct? So every time somebody receives some money, this person then decides to keep a certain ratio, maintain a certain ratio between deposits and cash. Correct? So this C, for instance, could be, for example, 0.05. What would that mean? 5% of deposits are always kept in cash form by people. So this is now allowed for cash leaks. Correct? So we've allowed cash leaks. Now, the next thing is, how are we going to allow for banks choosing not to be fully lent up? How do we accommodate that now? And this is how we are going to accommodate that. We are going to define something called bank's desired reserve ratio. And this desired reserve ratio could be bigger than the required reserve ratio. Am I making sense here? So for instance, if the required reserve ratio is 10%, then the desired reserve ratio could in fact be 15%. You see, so now we're allowing banks to keep more cash in their reserves than the Fed requires them to keep. Yes? So this is the case of banks choosing not to be fully lent up. Correct? So this then implies that the actual cash reserves that banks keep are being the cash reserves of banks, correct? So the cash reserves of banks is going to be equal to the desired reserve ratio times customer deposits. So instead of keeping 10% of deposits as cash, they are now keeping, for example, this number could be 0.15 instead of 0.1. 0.15 meaning 15% instead of 10%. Am I understood here? So this is how we're going to relax the assumptions. Yes? So let me go to a new slide here. I'd like you to keep two things in mind here. This and this. Yes? Of course, we also need to remember this and that, the formulas for money supply and monetary base. Okay? So let me go to a fresh slide here. And I'll start by writing out what money supply is. Money supply is C plus D. And what's monetary base? Monetary base is C plus R. Correct? Now what is C equal to? C is equal to lowercase c times D. What is R equal to? Lowercase r times D. Right? What is this lowercase c called? It's called the cash to deposit ratio of the public. This is the amount of cash that the public wants to keep. Rather, this is the ratio that the public wants to maintain between deposits and cash. And what is R? R is banks' desired reserve ratio, which could be bigger than the RRR set by the Fed. Yes? Could R, the lowercase r, be smaller than the RRR? In other words, could banks desire to keep less reserves than the Fed requires them to keep? Well, they may desire it, but they will still have to keep the RRR at least. Am I correct? Reserves can never fall below required reserves by law, right? So R, this R can only be like this. It can't be less than the RRR, because then the bank would be violating the law. Am I making sense? So now I am going to do the following. I'm going to divide the money supply by the monetary base. And this is going to be C plus D divided by C plus R. Now what I'm going to do is I'm going to replace C here by this relationship with, this equation for C. Correct? Also, I'm going to do the following. I'm going to replace this C in the same way. This C should also be replaced in the same way. And then I'm also going to replace this R by this expression for R. Yes? So then, what is my equation going to look like? So I shall have lowercase c times d plus d divided by lowercase c times d plus lowercase r times d. So far, so good. Now notice that we have a d here and d there. So we can factor out the d. We can write it like this: d outside of brackets times 1 plus lowercase c. Is that correct? Wouldn't that be equivalent to the numerator? Yes, because d times 1, that's the d. D times c, well, that's the c times d. Correct? Here, too, we will do the same. There's a d here and a d there. We're going to factor this d out. In brackets, we would have r plus c. Yes? And then we can simply cancel out this d and this d, and we are left with 1 plus the cash to deposit ratio divided by the desired reserve ratio plus the cash to deposit ratio. Yes? So what do we have in sum? In sum, we have ms divided by the monetary base is equal to 1 plus lowercase c divided by lowercase r plus lowercase c. This, of course, implies that the money supply is equal to, multiplying both sides by monetary base, 1 plus c divided by r plus c times the monetary base. Is that correct? Now, do you see how I got the last one? I multiplied both sides. Multiply both sides by monetary base. That's how I get this one. Correct? I'd like you now, in the end here, to take a good look at this, and I'd like you to compare this to this top formula here with the triangles erased. Let's erase the triangles, okay? So what do we have there? Money supply is equal to monetary base times money multiplier. Is that correct? Correct? Now, could we compare that to what we have now? What do we have here? Let's write the other one down. Okay, the other one has money supply is equal to monetary base times the money multiplier, correct? So what do we have here? Monetary base, monetary base. I'm sorry, money supply, monetary base, monetary base. So then what is the money multiplier? The money multiplier clearly then is this expression, is that correct? Right? So that is our money multiplier now. This is the money multiplier that accommodates cash leaks and also accommodates the fact that banks may choose not to be fully lent up. Right? So this is our new money multiplier. So let me write this down here on the side. So we have a new, new money multiplier. It is equal to 1 plus C divided by R plus C. Right? What was the old money multiplier? The old money multiplier was simply 1 divided by the RRR, correct? Let's compare these two. When would the two be equal? These two, the two would be equal if A, lowercase c was equal to 0. This is equivalent to no cash leaks. Is that correct? Cash to deposit ratio is 0. In other words, people don't like to keep any cash. They take all that money and put it into checking. Am I correct? So that's one. And the other thing would be that if R was equal to RRR, this means that bank's desired reserve ratio is exactly equal to the required reserve ratio. So this, of course, means that banks choose to be fully lent up. Do you see that? So the two would be equal if lowercase c was 0. In other words, we'd like this to be 0, this to be 0, and this to be equal to the RRR. Right? That clear? Now let's work with some numbers here to see what the values of these two multipliers would be. Okay? So let's say that the required reserve ratio is 0.1 or 10%. Right? Let's also say that the cash to deposit ratio is 5%. And let's say that the desired reserve ratio of banks is 15%. Let's work with those numbers. So what was this value going to be equal to? 1 divided by 0.1 is 10, right? Let's see what this is going to be equal to with these values here. So this would be 1 plus 0.05 divided by 0.15 plus 0.05. Correct? How much is that equal to then? That's equal to 1.05 divided by 0.20. How much is that equal to, somebody? How does that compare to the 10? .05 divided by 0.2, 5.25. So this is equal to 5.25. Let's compare that 5.25 to this 10. Let's compare these two. So what happens then as a result of cash leaks and banks choosing not to be fully lent up? The money multiplier becomes smaller. Correct? The money multiplier becomes smaller. Yes? Okay, now, let's finally summarize the ways in which the Fed can change the money supply. Ways in which the Fed can change the money supply. And we'll write the formula down, and that is change in money supply is equal to change in monetary base times the money multiplier. And let me work with the old money multiplier, okay, if you don't mind. I'm going to go with 1 divided by RRR instead of the new one, okay? I'm doing this for a reason. So one way in which the Fed can change the money supply is by the means of open market operations. Open market operations meaning buying and selling of bonds by the Fed. If the Fed buys bonds, what happens to the monetary base? This change is going to be positive if the Fed buys bonds, correct? This is going to be negative if the Fed sells bonds. So that's, in fact, the main way in which the Fed can change the money supply. Open market operations. Next, if you look at that formula there, what else can the Fed tweak, do you think, to alter the money supply? Can the Fed do anything to the money multiplier itself? In other words, could the Fed do anything to this here? Is that under the Fed's control? Yes, it is, correct? Right? Now, if the Fed wishes to increase the money supply, what would it do to the RRR, do you think? Lower it, precisely, because by lowering the RRR, the money multiplier becomes bigger. Am I correct? So the other thing the Fed can do is change the RRR. Lower it if the money supply must be increased. You see that? Because if the RRR reduces, that would cause the money multiplier itself to rise. Correct? If you reduce the denominator of that fraction, 1 divided by RRR, if you reduce the denominator of any fraction, the fraction becomes bigger. Am I correct? So that's the other thing the Fed can do there to change the money supply. Change the RRR. So that's something it controls, correct? There is, in fact, a third way now. And the third way has nothing really to do with this formula directly. And the third way is by changing the discount rate. And what is the discount rate? The discount rate is the interest rate charged by the Fed on loans it makes to commercial banks and other financial institutions. Just as you and I borrow money from our bank when we need to, our bank borrows money from the Fed when it needs to. The Fed is like a bank for banks, correct? And the discount rate is the interest rate that the Fed charges. Now, if the Fed wished to increase the money supply, this is what it could do to the discount rate. It could lower the discount rate. How would that work to increase the money supply? Lowering the discount rate would encourage banks to borrow cheaply from the Fed, take that same money, and lend it out to you and I at a slightly higher interest rate, making a profit. Am I correct? They would borrow cheaply from the Fed and then lend that same money out to you and I at a higher interest rate. We know now that bank lending causes the money supply to increase, doesn't it? Right? So lowering the discount rate will tend to encourage this type of behavior, which is banks borrowing cheaply from the Fed and then increasing its lending to you and I. And this increase in lending to you and I shall cause the money supply to rise, correct? On the other hand, if banks wish to reduce, if the Fed wishes to reduce the money supply, it will raise the discount rate. Now, if the discount rate is raised, what will banks do? Let's say that you have a bank that already has borrowed money from the Fed, but now the interest rate on this loan has gone up. Now, if the interest rate goes up, wouldn't the bank want to quickly repay the Fed? Do you follow me? For instance, let me give an example. Let's say you take out a mortgage loan, and you started with an interest rate of 3%, but now it's gone up to 7%. Wouldn't you like to pay off your house as quickly as possible? Right? In the same way, a commercial bank that has borrowed money from the Fed in the past will want to repay the Fed quickly if the Fed raises the discount rate. And how is a bank going to repay the Fed? It will have to call in loans of its own. It will have to ask people to whom it has lent money to repay. And we know what that does to the money supply. Remember when you got a call saying that you must repay the $900 you borrowed to buy a computer at Best Buy? What happened there? You went to your aunt, remember? And you asked her for the $900, and she went to her account and withdrew $900. This caused the sum total of checkable deposits in the country to go down by 900, correct? Then your aunt's bank had to call in loans of its own because after paying your aunt 900, it was short of reserves. Do you remember that story? So when banks start to call in loans, that causes the sum total of checkable deposits in the country to shrink, meaning money supply to shrink. Right? So when the Fed raises the discount rate, this is going to cause banks who have borrowed from it to call in loans so that they can repay the Fed. And this calling in of loans should result in the money supply shrinking. So the discount rate is the other way. So raise, oh, hang on, let me write it as lower, okay? So this will be lower it if the money supply needs to be raised. So these are the three ways in which the Fed can change the money supply. Of these three, this is the most important way, the buying and selling of bonds. Okay? And now in the remaining 7 minutes that I have, I'm going to quickly talk about the Fed. Okay? And I will go here quickly to my slideshow. Quickly. The Federal Reserve System, Fed, is the central bank of the United States. Other countries have their own central banks. England has the Bank of England, for instance. Mexico has the Banco de Mexico, etc. A central bank is a public authority that provides banking services to banks. So it's a bank for banks. And also regulates financial institutions and markets. Right? What's the Fed's main task? The Fed's main task is to regulate the interest rate. Now, this is something that we haven't yet learned. We will learn in our next chapter, how the Fed regulates interest rates. It does so, by the way, through the money supply, which we now know it can control. The entire country is divided into 12 Federal Reserve districts. So there are, in total, 12 Federal Reserve districts. And each district has its own branch of the Fed. Correct? So where is our branch of the Fed? Right here in Dallas. Right? So our Federal Reserve District covers Texas, New Mexico, and this, I believe, is what? What is this state? Pardon me? Louisiana. No, that's not Louisiana. Louisiana is on the coast. This is inland. I don't know. My American geography is not very good. But pardon me? Is it half of Louisiana? Okay, all right. Half of Louisiana. So 12 Federal Reserve districts. Now, of these branch banks, branch Feds, the most important one is this one here, the New York Fed. And that's because New York is one of the world's financial capitals, right? Wall Street is in New York, right? So the Fed of New York is what is considered the most important of all the branch Feds. Now, each of these branch Feds has its own president. So there are 12 branch Fed presidents there, right? On top of them sits the Board of Governors of the Federal Reserve System, and they are based in Washington, D.C. So let's look at the structure of the Fed here. So you have the chairman of the board. She is currently it's a person called Janet Yellen, who is a professional academic economist, right? Who's currently on leave from her university, acting as the chairman of the Fed. Okay? The Board of Governors is a 7-member board appointed by the president, confirmed by the Senate. Each member serves a 14-year term, and the president chooses one of these to be the chair. And the chair serves a term of 4 years, which is renewable. Okay? So you have these 12 Federal Reserve banks, and each one has its own bank president. And now we come to the most important committee within the Fed. And it's called the Federal Open Market Committee. And can you guess what this committee makes decisions about? Open market operations, the buying and selling of bonds. And this is a 12-member committee. 12 members. Of these, 7 are the Board of Governors. And then you have a remaining 5 chosen from among the presidents of the branch Feds. But of these 5, one position is reserved for the president of the New York Fed. The other 4 rotate. Okay, so this is the Federal Open Market Committee. They meet approximately every 6 weeks, and then that's when they decide whether they're going to continue buying bonds, or will they now stop buying bonds and perhaps start selling them, and so on. Okay? So this roughly is the structure of the Fed. And that brings me to the end of this chapter, end of my lecture. So you have enough information now to tackle your homework this coming weekend.